Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 11th, 2025, which was about 5 days ago. The big idea is a system that uses large language models to write Blender Python code for 3D assets, turning shape generation into code that artists can read, edit, and reuse. The paper is titled LL3M, Large Language 3D Modelers. And as we will see later, the implications for creative control and iteration are quite significant. Beyond first results, the system coordinates specialized agents, retrieves Blender knowledge on the fly, and supports iterative, human-guided refinements through clear, modular scripts. Building on that, the tweets highlight LL3M turning text into editable Blender code for shapes, materials, and scenes, emphasizing easy modification and interpretable scripts. Engagement looks solid, with around 279 likes on one post. Also, the authors shared a GitHub repo, but it's essentially a placeholder right now. You'll find a minimal README, MIT license, and a code coming soon note, plus stars and basic metadata. No releases or examples yet. So, the implementation is accessible on GitHub, with code promised shortly. Alright, this opening figure showcases the end-to-end flow. Starting from text prompts on top, the agents generate Blender code panels below, which then render the purple hat, lantern with candle, and the blue fish. Notice the green highlighted lines that mark key parameters the agents tweak during refinement. Building on that, the rightmost code snippet illustrates a simple manual change to a resize value, and the fish updates without rebuilding the rest, highlighting localized, editable control. Next, this visual emphasizes why writing code helps generalize across shapes. Focus on the graphics above the caption, where 3 different objects appear side by side. Despite looking unrelated, each uses the same Bezier curve operation to form a tail, a pair of handles, or a wireframe. Building on our earlier point about modular edits, a single reusable pattern becomes a shared building block, so the agents can transfer know-how while keeping each asset editable and localized. Now we zoom into the method overview. 3 panels show the pipeline from text to editable 3D code and renders. The top lane depicts planning, retrieval from Blender docs, then coding to produce the first mesh. Moving on, the middle lane adds automatic checks, a critic flags issues, and verification confirms fixes. Finally, the bottom lane illustrates user-guided refinement, where a short instruction tweaks parameters, and the verification step ensures the change sticks. Moving to this comparison, the top row shows outputs without the retrieval database, while the bottom row shows results with the Blender RAG knowledge. Notice how the windmill, rocket, and lantern gain richer geometry and materials when retrieval is enabled, including multi-part blades, layered rocket bodies, and detailed lantern struts. The key message is that retrieval unlocks complex Blender functions, so the coding agent goes beyond simple primitives and produces higher quality, more expressive meshes. Alright, this table quantifies the impact of the retrieval module. Focus on the 4 columns: complex with retrieval, complex without retrieval, errors with retrieval, and errors without retrieval. The averages tell the story. Complexity jumps from about 1.2 to 5.86 when retrieval is enabled, while errors drop from 3.29 to 2.43. In short, retrieval unlocks richer Blender operations without causing more failures, which translates to more expressive assets at comparable or lower debugging cost. Building on those metrics, 2 takeaways stand out. First, treating 3D creation as editable Blender code delivers modular assets that users can tweak locally without rebuilding everything. Second, retrieval-augmented knowledge markedly boosts complexity while cutting errors. Blender RAG simply means a retrieval system grounded in Blender documentation. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.